finding area, we're going to expand upward and find volume. It's going to be awesome. Okay, so the idea is we're going to have this base, which they're going to use the base just like we did in the last section. Okay, so they're going to use a function, and they're going to bind a region. They'll have this little area, and then what they're going to ask you to do is they're going to ask you to like build on top of that. Okay, so can you visualize it?
So we're making a 3D graph in our brain.
Yeah, in your brain. Absolutely. Okay, so here is an example that I found. So let's say, see the little part on the right over here? This piece right here. So this is like what we did in the last section. Okay, so we were able to find the area of this bounded region. Okay, so now what they're going to ask you to do is to build upward, and they're going to use nice shapes. Okay, so let's say they're going to ask us to use a nice triangle, an equilateral triangle, because that's really nice. We can find the area of an equilateral triangle very easily. Okay, so you can see like this going up, but it's not just one little slice, it's a whole bunch of slices on through that region. So let me show you what that looks like, the infinite number of slices. You see how it fills in?
Oh. Is it going down?
Yeah, it's getting smaller because it's an equilateral triangle and it's going towards a point. You see it? Okay, so now I can take that 3D object and move it around in space. And that's what we're going to be finding. Okay, so here's kind of a cooler one. I think that the one that's like, let's do a semicircle this time and let's reset it. Okay, so actually I already have it filled in, that's okay. So notice how like on this one, see if I can pull this up. The bottom of this is flat. Okay, so you're like, it's kind of like thinking of a house, I guess. You're building upwards off of a flat surface. Okay, and that's why it's called a cross section. Okay, so that's what we're doing today. Are you ready? Yeah?
You said circle.
Oh, let's see. Yeah, it turns into a cone. I know, yeah, like it was perpendicular to that flat surface. Yeah. So the idea of a cross section is that whatever shape you're using is going to be flat on the base of it will be flat to the base of your base drawing. Does that make sense? Okay, that's important. That is a requirement. Okay, so let's do this on here. Couple of formulas. Okay, I think you know all of them except maybe the equilateral triangle. So maybe take a quick look at that and absorb. Got it? All right, here we go. All right, so for question number 1, they give us this bounded region. Okay, so this is going to be our base. See our base? It's bounded right here. They already drew the line -2x plus 2 for us. Okay, and they're going to ask us in this question to do squares that are perpendicular to the x-axis. Okay, now that is really important information. Okay, because the squares are perpendicular to the x-axis. So they're vertical squares, right? Did you think about it? Okay, so I have these little squares that are like vertical. Here's just one example of one of the little slices. Okay, so in order for me to do this, I need to know what those vertical heights are. I need to know what the area of a square is. Okay, what is the area of a square? Side squared, right? As long as you know the side. Okay, so these sides, this is the length of a side, are going to change depending on where I drew my slice. What is the length of my S? What is this height right here? How would I find it? Okay, yeah, you plug it in wherever it is on that y equation. Okay, so the S on this example is -2x plus 2. depending on where our slice is. Okay, so we're just going to use that equation because we can move that slice anywhere. Okay, so now they already set this integral up for us. You see the volume is equal to, notice that it's already filled in our bounds for us. Okay, so we're looking at the x bound going from 0 to 1. You guys see that on the picture? 0 to 1. Okay, and it already filled in the area of a square, which we already said was s squared. So all we're going to do is we're going to replace the s with this equation that we wrote. Okay, so the volume is going to go from 0 to 1 of negative 2x plus 2 squared dx. Okay, so let's go ahead and solve this really quick. How do I integrate a quantity that is squared? What's that? Okay, I can absolutely use the general power in this case because the derivative of the inside is just negative 2. So there's nothing on the outside that's stopping me from doing that. Let's go ahead and do the general power rule. Whoops, I don't need the integral because we're going to integrate it. So it's going to be the derivative, or excuse me, the integral of the outside. So my new exponent is going to become 3. And then I have to divide by 3. And then I also have to divide by the derivative of the inside, which is negative 2. Okay, so I need to do that from 1 to 0. 0. Okay, and so I'm going to do big minus little. So I have negative 2 times 1 plus 2 cubed over, I'm going to call that negative 6. Minus, if I plug 0 in, negative 2 times 0 plus 2 cubed over negative 6. All right, so let's math this out. So we got negative 2 plus 2 is 0. 0 cubed is 0. 0 divided by anything is still 0. So we got 0 for the first one. Okay, on the second one we have 0 plus 2 is 2. 2 cubed is 8. And 8 over negative 6 is negative 4/3, right? So minus a negative, so can I go ahead and say plus 4/3? Or you can say 8/6 if you feel better about that and then simplify it, yeah. Okay, so we get a positive area, or excuse me, positive volume, not area. If they don't give us increments, you do not. If they said in our equation somewhere about feet or something, then we would. But if they have no increments, we don't have to label it. Good question. All right, so let's just focus on the setup of this because that really is the hard part right now. Okay, so let's start with question number 2 here. Okay, so this one, they're using the same base area as question number 1. So we're looking at the little triangle. But this time we're going to use semicircles that are perpendicular to the x-axis. Okay, so let me draw this visual to the best of my ability. I do not claim to be an artist. Okay, so perpendicular to the x, so the base of the semicircle is going to be just like the squares. Okay, so you're kind of envisioning this top half of a circle coming upward, right? Do you see it in your brain? So it's going from 0 to 1, excuse me. Okay, so the first thing that I need to know is what the area of a semicircle is. So what is the area of a semicircle? 1/2 pi r squared. Okay, now immediately I look at that and go, uh-oh, we got a little bit of a problem here. Okay, because if I'm looking at this semicircle, this length right here, that whole bottom length, it's not a radius. It's a diameter. Okay, so that's kind of a thing I need to be thinking about. I need to think of this in terms of radius rather than diameter. So what do we know about the radius and the diameter? Yeah, right? So the radius is equal to 1/2 of the diameter. Okay, and so the diameter in this case is going to be the same as the s that we did in question number 1, right? That's the equation, negative 2x plus 2, depending on where our slice happens to be. Negative 2x plus 2. And so now what I can do is I can say, okay, well, if my D is negative 2x plus 2, what's my R? Ooh, okay, so you did that in your head. Absolutely okay. Did anybody say 1/2 times negative 2x plus 2? Okay, whatever floats your boat. I'll write it out because I feel like it's more descriptive. But if you want to simplify it, go straight to it. Okay, now we can plug that R value into our equation and write our integral. Okay, ready? So the volume is equal to, what are our x bounds? What two x bounds do we hit? 0 to 1. Okay, times the radius. Or excuse me, not the radius, the area. Okay, so the area of the semicircle is the 1/2 pi. And then I'm going to fill in my R. So R is 1/2 negative 2x plus 2 squared. And what do I write this in terms of? What's the variable I'm using? Dx. Okay, so that's just the setup. How do we do? Is the squared? The squared is from the area of a semicircle. 1/2 pi r squared. That's where that's from. Good, okay. Okay, let's do B. So this time, for B, we're talking about rectangles with a height of 1/4. Ooh, I like that. Ooh, perpendicular to the y-axis. Very important information right there. Let's draw a picture. I'm a visual learner. Okay, so this time we're drawing rectangles with a slice this way. Okay, so immediately what I notice is that our equation that was y is equal to negative 2x plus 2. Now if we're going in terms of the y in relation to the y-axis, I need to take that equation and I need to solve for x. So we're now in terms of y. Okay, so if I take that equation and solve it for x, what would I do? Subtract 2, and if you did that in all in one step, good job. Y minus 2 over negative 2. Okay, so that's the equation now. It's in terms of y this time. Why? Because see how it says perpendicular to the y-axis? That means our equation has to be in terms of y's. Okay. All right, let's talk about the area of a rectangle. What's the area of a rectangle? Okay, I'm going to use base times height. But yes, base times height. Just because the base is like the base of our little thing. So the base is this slice that I just wrote. Okay, so what is the length of my base? Oh, I erased it again. Dang it. The base. Okay, so my... I got this. It never erases when I want it to. But if I try to just... Okay, anyways, you guys see what I'm trying to draw? Okay, I'll just point. This length right here. Okay, that's my base. So what is that length of that base? I just found it. Same as x. Y minus 2 over, whoops, that's not a 2. 2. Yeah. Okay, and then what's my height? It says in the directions, the rectangle with a height of 1/4. So what's my height? 1/4. That's a very literal, and I like that a lot. The height is literally 1/4. It does not change. Constant value. Okay, so now we're ready for our integral. Are you ready? Okay, so this time we're doing volume from the lowest y value to the highest y value. What's the lowest? We might have to look at the picture that had a better drawing up above. 0 to, what's the highest y? 2. See where I'm looking? Up here. Do the y, yeah. 0 to 2. Okay, so of the area, which is the base times the height, I'm going to put the height in the front because I like the constant in front of the quantity. 1/4 times the base, which is y minus 2 over negative 2 dy. How do we do on that one? Awesome. Good. Okay. Check. Okay. Example 3. So example 3 is a little bit harder because they don't draw the picture for us. So we have to do a little bit of drawing so that we can kind of visualize, at least I do. I'm going to draw a picture. Okay, so we have, let's see, we have two equations, negative x squared plus 2 and x, and we're going to do a cross section with squares perpendicular to the x. Okay, let's start by just drawing our flat base. Okay, so what does negative x squared plus 2 look like? Upside down parabola, specifically moved up 2 units. Very good. Boom. Beautiful. Okay, and then what does y equals x look like? Straight line with a slope of 1. Perfect. Okay, so we're going to be drawing little squares that are perpendicular to the x-axis, so that means up and down, vertical. Okay. All right, so the first thing that I'm going to do is I'm going to find my bounded region of my base. Okay, so I need to first figure out where these two lines intersect, the specific x values where they intersect. Okay, so how would I figure that out? Set the equations equal to each other. So I have negative x squared plus 2 is equal to x. Okay, so I'm going to go ahead and solve this quadratic by pulling everything to the right-hand side so I can try factoring it. So I'm going to say 0 is equal to x squared plus x minus 2. And now I'm thinking, what two numbers multiply to negative 2 and add a positive 1? What? Yeah, negative 1 and positive 2. So our intersection occurs at positive 1 and negative 2. Okay, so that's our bounded region, the interval piece. Okay. All right, so now let's talk about the area of a square. Okay, so the area of a square is what? S squared. Okay, so this red length that I drew over here is a length of S. Okay, how do I find that length of S if I have two functions that are binding it? Thank you. So, are we thinking about this? Okay, so the top height, okay, do you see what I'm saying? Like, so the top height from the x-axis to the parabola piece is a height of negative x squared plus 2. But I also have to add in the height between the x-axis and x. So what is my total length of S? Plus x, exactly. Just add them together. Okay, so my S is negative x squared plus 2 plus x. Okay, so now I have enough information to write my integral. So my volume is going to equal the integral, okay, between which two x values? Negative 2 to 1, good. And then since my area is s squared, I'm going to have negative x squared plus 2 plus x. If you wrote that in its actual correct form, good job, because I would like that better the other way too. And then don't forget to square it because it's s squared for the area. Dx. How do we do on that one? It should be oh, good question. Because why? Right, I think you have the right idea. It should be a minus. Why should it be a minus? He's exactly right. This minus the x. He is right. Think of it up here in the first quadrant. It would definitely be a minus. And then what happens on the bottom one is because what do you know about the y value in the third quadrant? It's a negative. So if we add a negative length, that would be wrong to do, right? We want to add a positive amount of length because it's clearly getting longer. So it should be a minus. You're right.
What about the other side?
So on the other side, it would be a minus because on this side, it's a positive height.
So it'll be plus x over there.
Nope, it's going to be minus x in both scenarios. Because see how right here, if I'm looking in the first quadrant, I have a positive height minus a positive height. You see what I'm saying? I have to subtract them to get that space in between. On this one, my height would be a negative, but I want to add it. I want to get a positive, longer height. Right? Because this height would be like -1, let's just say. I want to add one and not subtract. Good catch, Hunter. Are you still? Now have you confused yourself? Oh, interesting. Well, either way, you found you're right. So. It kind of was. Okay, are we ready to go on to the last one? Are we okay with that?
Because that's the answer.
Yeah, well, that's the integral piece. Yeah, just the setup. Okay, last question. This one is kind of an interesting one because of the circle scenario. So the issue with this idea is that they give us an equation of a circle. And what's the problem with the equation of a circle? What's the problem with the equation of a circle? Yeah, you have x and y's on the same side, and it's technically not a function. Right? It doesn't pass the vertical line test. Okay, so you have to be really careful when you do this, because when you do integration, it's got to be a functional. Okay, so we have this base, which is a circle, and we're going to do equilateral triangles that are perpendicular to the y-axis. So that means everything has to be in terms of y. Okay, all right, so step one, let's start with the area of an equilateral triangle. Remember I told you to glance and memorize it really fast? Did anybody do it? Square root of 3 over 4. What's the variable they use? S squared. We'll use an S. That works. Okay. All right, so here's my slice. Let's just put it right here. Okay. So the S is long. No, you can put it anywhere in between, as long as it's just perpendicular to the y-axis. Anywhere. Where was I going? Okay, so that blue is a length of S, right? A whole length of S. Whoa. Okay, so we need to figure out what the equation of the length of S is, and our equation is x squared plus y squared plus 1. Okay, so remember we want this in terms of y, so that means we need to take the equation and set it equal to x. Okay, so let's solve this for x and see what happens. Let's see, we subtract the y squared. No, because it's on the y-axis. And then we square root it. So when we square root it, we basically end up getting two separate equations. So this is an equation for the left part of the circle, and then the positive one is for the right side of the circle. Okay, so what is the distance of S? The square root, you're very close, because the square root of 1 minus y squared is 1/2 of the circle. So we need 2 of those lengths. There you go. Okay, so do you see what I'm saying? So like this x length is only from the y-axis over. Okay, so to get the s, we would have to multiply it by 2. 2 of those. Okay, so now I should be good. Are you ready to set up the integral? All right, so remember you're thinking in terms of y. What's the lowest to the highest for our bounds? -1 to 1. And then the area of the equilateral triangle, the s length is 2 square roots of 1 minus y squared. Squared dy. How do we do on that one? That one makes sense?
Why are we using the equilateral triangle formula?
Because it says to in the directions. I didn't just pick one, I was told to choose that one.
But how did you know
What it was? If you turn the page back, there's one right next to your elbow. Well, okay, higher. Right there. The very far one. Okay, last one. Are you guys ready? This one isn't too bad. Yeah. Yep. So there's two sides, right? So the positive is this side, and the negative is this side. It's two equations. Right. Okay, so for B, we're going to do some rectangles. Okay, so we're still going to do rectangles perpendicular to the y-axis. Okay, so the nice thing about this is that if you imagine now rectangles, we still have our s length is still exactly the same as the s from the equilateral triangles, so we don't have to develop a new s. What we want to think about is first, what is the area of a rectangle? Base times height. Base times height. And we know that the base is our s from before, right? So our b is 2 square roots of 1 minus y squared. And then the height says, the heights are 3 times the base. So the height is equal to 3 times the base. Okay, so if I was going to just kind of plug the h into the equation that I have up here, I would have b times 3b, which is the same as, what? 3b squared. 3b squared. Okay, so we know that the b is the same as this s over here, 2 square roots of 1 minus y squared. So we can plug this in now. So our volume is going to be from -1 to 1 of 3b squared. I'm going to replace the b with 2 square roots of 1 minus y squared. Then square it, dy. Make sense? Okay. Mind blow? All right. So your assignment you have to get done by Monday is 1 through 14. If you choose to do more problems and do the whole assignment, it's worth extra credit to you. Yep, you got to do 1 through 14.